Welcome to the latest episode of the MFG Radio Network's Manufacturing Matters, where industry experts take deep dives into the latest technologies you need to consider to keep manufacturing moving. Welcome to our latest roundtable discussion, Improving Manufacturing with Proper Tool Holding and Work Holding. I'm Jake Kaufman, the Associate Editor for the Manufacturing Group here at GIE Media. Our panel of tool holding and work holding experts is standing by, waiting to answer questions about new work holding and tool holding systems, providing manufacturers with better results, more unattended machining, and increased machine uptime in metalworking operations. We'd like to take this time to thank our sponsors, Big Daishawa and SMW Autoblock. As a member of the Big Daishawa Group in Osaka, Japan, Big Daishawa Inc. has grown into a recognized global tooling provider with manufacturing facilities in North America, Japan, and Switzerland. In addition, Big Daishawa is the North American representative of Speroni tool measuring machines, Sphinx high performance drills, and MPTEC measuring stands, and Takusa spindle cleaners, and the Unilock 0-point work holding system. Now, SMW Autoblock is a work holding company focused on achieving customers' goals and expectations with the highest quality products and services. SMW Autoblock combines stock standard product with a highly trained sales, service, and engineer team that is consistently providing the ideal work holding solutions to customers across a wide variety of industries. The organization strives to achieve a deeper understanding of customers' needs to provide products and services geared towards specific customer applications, maintaining long-term mutually beneficial partnerships to enhance machine tools and drive modern manufacturing. Now, before we get to the discussion, let's hear a little bit about our two panelists today, as we have John Zaya from Big Daishawa. He is a product specialist, and as a product specialist, Zaya is responsible for identifying and recommending the most suitable products for customer needs, as well as providing technical support and training on the use of the products. He has a strong background in the field and has earned valuable experience at various machine shops before joining Big Daishawa in 2006. He holds a Bachelor of Science degree in Mechanical Engineering Technology from Michigan Technological University. And Larry Robbins is the president of the commercial division at SMW Autoblock. Larry joined SMW Autoblock in 2007 as a national sales manager and recently was appointed president in 2019. As president for SMW Autoblock's commercial division, Larry is responsible for all strategic sales and marketing initiatives, as well as overseeing SMW Autoblock's North American sales team and customer base, which does include machine tool dealers and OEMs. He oversees various projects internationally. Larry has over 35 years of experience in machine tool manufacturing. And prior to working at SMW Autoblock, he owned a successful manufacturer's rep company for 13 years. Larry's expertise in the machining industry began in his early youth when he worked side by side his father, who owned a prosperous distributorship in New York. And now that we know each of our panelists a little bit, we can begin the discussion. We begin with John over at Big Daishawa. So John, now that we are here in 2023, are there any new advancements, technologies, products that you guys are rolling out this year that you're excited to get onto the market?
Sure. So we've been expanding a lot of our product lines, both on tool holding as well as work holding. We've done a little bit of trimming the fat on some of our work holding as well, but on our tool holding, we've expanded a lot of our smart damper systems, which are our anti-vibration tool holding, to include blade options, additional boring options. We've done this because we've recognized a lot of our customers are using these now because they are really providing a huge benefit to their operations. They're noticing a little bit more higher productivity because the cutting is working a lot better. The decreased vibration leads to increased tool life, which then leads you to decreased cost because you're not replacing inserts. Your consistency is there as well when you're cutting. Your work pieces don't have as much surface finish problems, so there's less reworking things afterwards as well. We are also looking at expanding some of our tooling lines to include some of our smaller target ranges. So on the milling side, we're looking at introducing a smaller milling chuck. Previously, we had released one a couple of years ago that had some really good success. And now we're expanding that even more to a different variation, which is what we call our Mega 12DS. It's a 12 millimeter maximum capacity milling chuck. Previously, the old version was what we call the high power milling chuck. And so the Mega version just improves that even more. And so this is really geared towards the customers that are taking advantage of high efficiency milling or tricoidal milling, where they're really after complete flute length engagement, which causes higher axial pull-out forces. And so by having a milling chuck, which is better than a collet chuck, even at these small sizes, you're able to reap the benefits of high efficiency milling. And then a little bit later, I'll get into some of the real nitty gritty about a product that we've been working on for the last couple of years, which is our EWA auto boring system. Not to get into too much detail, but it's a closed loop fine boring system that allows you to essentially pull the person out of that loop and do everything on the machining center. So we've got lots of new products that some of it we brought out at IMTS and more that we'll be releasing throughout this year to help customers achieve those goals that they're looking for.
Awesome. Thank you, John. So we head over to Larry with the same question. What will be new from SMW Autoblock in this coming year? What kind of technology, products, things like that are you working on?
We're almost the opposite of Big Daishawa. We are almost totally focused on work holding, design and build, standard and special work holding. And just for the audience's advantage, in our facility, we use nothing but Big Daishawa boring. So it's excellent quality. You guys will have nothing but the best success using their tooling and their expertise. Where we strive is constantly innovating in the work holding arena. Probably our biggest and newest solution or most earth-shattering solution is we're introducing electronics and non-contact transfer of power and data to work holding implements. Historically, work holding has been powered three different ways: manually, hydraulically, or pneumatically. The problem is, over the years, because of the way the industry has changed and the way things are being handled, the minute you introduce any kind of oil, coolant into a manufacturing environment, it becomes hazardous waste. Most of our new work holding technology is fully sealed. And when I talk about electronics, I'm talking about the ability to transfer through an air gap of up to 10 millimeters, depending on the size of the sending unit, power, data, and safety features back and forth between work holding implements, whether they be chucks, swing clamps, fixtures, vices. We can monitor, we can give ID information, amongst many other things we do as a work holding company.
Awesome. Thank you, Larry. So we stay with you for our next question. Now, let's say you are a shop that is starting from scratch. How do you make sure that you choose the right tool holding and work holding systems for your application?
Flexibility, flexibility, flexibility. And you'll hear it a lot of times during the day. I use that word. I almost use it as much as people use the word partnership. If your system is not flexible and doesn't have the ability to adapt to future jobs or future manufacturing solutions, you should question what you're purchasing. You know, the days of old, you would buy a vise for a milling machine, you would buy a chuck for a lathe. That was your technology. Now, with the combination of mill turn centers and newer 5-axis machines that have turning capabilities, it's added a whole new facet to manufacturing. So the ability to have flexibility and the ability to take standard off-the-shelf product, add some special touching components to it, and give the customer a solution that's flexible enough for their now and in the future.
Okay, awesome. Thank you, Larry. Now, John, over at Big Daishawa, if someone were to come to you and wanted to start up their own shop, what would be, the kind of things that you would look for in order to make sure that they have the right tool holding and work holding systems?
So whenever I talk to a customer and we're kind of getting started completely from scratch on a new project, I always first follow the KISS rule, keep it simple. Don't overcomplicate things at the very beginning. Let's look at where you got to start and where you have to end up and find the simplest solution that gets you started. Now, KISS doesn't necessarily mean you have to go cheap, but you have to use standard product that is readily available, that at least gets you started, gets a baseline, gets you in production, and then once you get that running, then you can start looking at optimizing by a couple of different methods. For me, the simplest method at that point is increase or decrease something, your feed rate, your speed. See what happens. If it breaks something, then that means that's a weak link you need to fix and try and find a different solution for. So when it comes to tool holding is pretty straightforward. The simplest rule is shortest as possible is always best. And that's not always the final solution. Sometimes you have to look at work holding, and sometimes combining the two, or finding a solution on the work holding side by elevating a part or moving a part in a different manner that gives you more access, gives you the ability to shorten your tool length assembly. So on a 5-axis machine, that's incredibly important. When the part's rotating, you have to consider all of that. So knowing that at the very beginning, by simulating things at the very beginning, before you buy a machine, before you buy tooling, before you buy work holding, run through some simulations, download the machine model if you have it, get tooling models, work holding models, do some of that initial legwork before you spend $1 on anything else. And then that'll help filter out what you can't and can use.
Okay, awesome. Thank you very much, John. Now, on the other side of the coin, if you do have a customer that already has a system in place, what are some things that you have to look for in order to make sure that that system is running most efficiently?
So, like I mentioned, if you make a small tweak to your operating parameters, that lets you know potentially a weak point on your cutting tools and your implements, your grade selections on your inserts and things like that. That gets you a very quick turnaround for figuring out what kind of cutting implements are not working correctly. When you get to a certain point, you can't increase your feed rate any further. Then you have to start looking more holistically as to the whole approach. Are we doing everything that we can to optimize the roughing process if it's on another machine? Is the finishing process staying in this machine, or would it be better to move finishing to another machine that potentially has more accuracy because it hasn't been worn out over all these years, or maybe it's got better scales or a different type of measurement system, or if it has on-machine probing that lets you do in-process measuring. Those are all things that you can look at to potentially increase your optimization of that part. When it comes to tool holding, there's a variety of different options that are available to a customer that if they are finding a limitation due to balance inaccuracies of a tool holder, that's where looking at upgrading from a hexagonal nut ER collet chuck to a cylindrical nut tool holder like the ones that we offer gives you better balance and then thus gives you better tool life. If you're doing long reaches, like I mentioned earlier, we've also have our smart damper system for milling applications. Those are other ways to improve on the tool holding side, the longevity of a tool holder and its operations.
Awesome. Thank you, John. So Larry, same question to you. If you do have a customer that calls up SMW Auto Block, what are the things that you kind of walk them through to make sure that their existing work holding system is running efficiently?
We try to look at the entire picture. We'll look at where they've started, where they want to end up, and where they are currently. Again, I'll use the word flexibility. As long as what they have allows for flexibility or is inherently flexible, where you can make change to adapt to the future of the manufacturing process, that's usually the simplest explanation to a solution. What generally happens is a customer will call you in when they have a problem. You judge it by the customer, their specific application, and try to build flexibility into a system they already have. A lot of times what you realize is somebody sold them something they should have never bought originally. And the most painful part of the conversation is explaining to them, I understand that you've spent a few $1,000s to start with, but if you really want to make this optimal, we're going to have to replace certain components. We try to reutilize as much of their existing system as possible, but systems are constantly changing and updating. A lot of our systems now have gone from open screws to sealed screws and sealed bodies to keep outside contaminants away. Quick changeover, setup reduction and optimization, having the ability to take and go from one fixture to another and be within 2.5 tenths guaranteed part to part. And, you know, John hit the nail on the head. As short a projection away from the table faces you can get without jeopardizing having to extend tool length. So there's got to be a balance in between there. And again, flexibility is what it's all about.
Awesome. Thank you, Larry. So then going on, once you do have an existing system, what are the things that you should consider as a customer before adding to or scaling up your operation in tool holding and work holding?
Take a look at all the available products. You know, it's very hard to tell people to go look at a competitor, but we implore with customers to look at every different solution, because generally they end up coming back because we first of all have the broadest offering of standard work holding product on the market, bar none. What that allows you to do is take off the shelf standard product, add a few special touching components to it, and have a custom solution. But if I crash it, now I'm not waiting 4 months to make a new one. I duplicating my tooling, getting a product off the shelf, I can have a customer back up and running in a few weeks rather than a few months. So again, flexibility, rigidity, just commonality. Try to keep work holding from one machine as common as you can to the next machine, because invariably a machine will go down at some point. You have to have the ability to take that important job and move it to another machine and not miss a beat.
Awesome. Thank you, Larry. So yeah, John, over at Big Daishawa, when a customer does come and say that they want to scale up their operations, what are the things that you tell them to kind of be on the lookout for? What are your suggestions for them to scale up or to increase their operation?
Sure. So when a customer is looking to increase the capabilities of what they currently have or add to it, basically what we try to do is find what has been working and maintain that. So if that means using the same family series of collet chucks or the same grade of insert on a boring tool, keeping those things consistent is the best thing that you can do because they're known variables. But also keeping an open mind to potentially new grades, or if you need an additional length of tool holder, staying within that same family means you know that the collets that you currently have are going to be reused. The accessory items are going to be reusable because you know what you're getting. It's just a slightly longer length. But in terms of optimizing performance, that's where working with industry experts, both on the tool holder as well as the different cutting tools that you're using, really comes into play. You have to tap into those resources that, for example, although we sell a line of drills, we don't sell any end mills. So that's where using multiple vendors and tapping into multiple vendors and their resources, online forums, all of those places are good information for a customer to look at to expand the capabilities of what they currently have. Modularity is also something that, as part of the Kaiser boring system, has always been at the heart of it. So anytime that you can use modular components over and over again, take advantage of that, because it's going to give you the ability to keep that value and just move it to another place. So if you need a longer reach it's easy enough to just add an extension into a head assembly to gain that additional length that you need. It's not reinventing the wheel over every single time.
Awesome. Thank you, John. Now, for our next question, we'll stay with you, but this is something that both you and Larry can have already kind of touched in on. So if there's anything that you guys can elaborate, but from a small job shop to like a large operation, how does having the correct tool holding or work holding system in place help impact your production?
So the biggest thing that I try to advocate with a customer is find the bottleneck in your production line. So if it's a single operation or if it's everything coming off of a machine is causing a bottleneck and causing things downstream, then that's where you need to really focus. Once that bottleneck has been opened, then you'll find another one somewhere else. And so eliminating bottlenecks, whether it's an individual operation or series of operations within a part process, is key to any improvement or any continuous improvement process that anybody has. So if this means you have to look at individual cycle times for different operations rather than the total cycle time, then you have to be very acute on that viewpoint and say, let's look at every drilling operation, every milling operation, and find the bottleneck within that group. Bottlenecks occur also due to humans. If a person is responsible for loading and unloading a part, then that time spent can be a bottleneck that's keeping production back. So that's where later on we'll look at, what we can do to reduce that by automating that loading and unloading of the part or the fixture. So finding bottlenecks, I think, is the biggest key to any improvement. If a tool holder seems like it might be a part of the problem, there's a variety of different holding options that a company like Big Show can offer to test and see, okay, does switching from a collet chuck to a hydraulic chuck give you better performance? Well, naturally it should. A hydraulic chuck is going to be better at run out. So that means your tool life should be better. Or if you take the other approach, you should be able to get more performance out of that tool. So that'll open up that bottleneck. So there's different avenues that customer can take on the tool holding side to eliminate those issues. It's just having the openness to say, okay, that's not working. I'm gonna not tuck my tail, but bite the bullet a little bit and say, okay, that's not working. Let's try something else and move on, and then find another problem to fix.
Awesome. Thank you, John. So Larry, will ask you the same question, whether it be a small job shop or a large scale operation. How does having proper tool holding or work holding impact their production?
Sometimes it's a bigger effect on a small job shop than it is a large job shop. A large job shop usually has a lot more experience. There's a lot more flexibility built in, just based on their experience and the size of the company and the resources they have. We approach every situation as if it's a large customer. We take everything, or as it's a small customer, we take everything with a personal touch. We have a full engineering staff. We have a full application staff. We have a full sales support and project management staff. So we support the customer from the beginning of the project all the way through to the end result. Having the ability to be flexible again, and I know I've said it 1,000 times and I'll apologize now for using it, overusing the term, but flexibility is what it's all about. As long as you can give the customer flexibility and the ability to have the ability, or you have the ability to be flexible and suit the next situation that comes down the pike, that usually becomes much more important for a small shop because it's all financial. When you look at a budget and a larger company has millions of dollars versus thousands of dollars, you have to take that into account when you're making recommendations. A sales professional generally will look at a situation and assess the value that the customer is going to see in return. We try to implore upon our people, it's not always about dollars, it's about what makes sense.
Awesome. Thank you, Larry. So we will stay with you for this next one as well. Now, when it does come to having proper tool holding and work holding, what does that mean for the tool length? And then if you do increase the tool length, tool life, how does that then help on your return on investment?
Well, it's kind of a, and I hate to be, I don't want to come across as cocky, but it's kind of a common sense answer. The more rigid your setup, the less you're going to have wear issues or chatter issues or issues that are created by length of tools versus length of work holding. And John said it again before, the stubbier you keep everything and the closer you stay to the spindle face, the less possibility you're going to have for vibration or premature wear on your cutting tools and your work holding. You have to remember, Chuck, as you function any kind of work holding implement, you're, especially with hydraulic force, it creates what they call an oil canning effect. As you close the whole chuck body flexes. So over time, what that does is creates wear on the chuck body and fatigue to the material. Eventually you have part failure. We combat that by process that we do through the manufacturing process, by heat treating every component up to 16 inches is hardened. Anything above that is case hardened. So we try to lay that oil canning effect by giving a customer a high quality product with years of predictable performance.
Thank you, Larry. So John, we go to you with the same question. With proper tool holding and work holding, how can that affect the tool life? And then how does that in return affect your return on investment?
Sure. So when it comes to tool holders and tool life, the biggest enemy is vibration and chatter. So if you're using a collet chuck, for example, and you're picking up a lot of chatter on the surface, that means that you're causing vibration, and that tool holder and the collet within it are vibrating and are going to eventually wear. Your cutting tool is potentially going to break. And so reassessing the operating parameters is kind of the easiest thing that a lot of customers will do. You know, they'll adjust their feed or their speed or their depth of cut. But eventually even that gets to a point of diminishing return of trying to figure things out there. And then you have to really step back and say, okay, maybe we need to step away from a collet chuck and look at a milling chuck, which is physically a different type of clamping mechanism. So that eventually gets to the point where you reach the ability to hold on to the cutting tool with the right amount of gripping force such that it doesn't vibrate and it's still able to perform and not have any chatter present in the cut. So gripping force is certainly one aspect of it. Run out is kind of another aspect. So when you're trying to generate your finished surfaces that need very tight tolerances to the finished quality or to the size, that's where you're not necessarily concerned about removing a lot of material, you're trying to control it. So you have to gain control by improving the run out of that tool holder. That's where you get into now hydraulic tool holding, not because it can do a lot of chip removal, but it's the control that you get, the run out that you get out of a hydraulic tool holder versus a milling chuck or collet chuck. So we always look at different types of tool holders to improve different aspects of the machining process. Whether you're at the roughing stage or the finishing stage, you shouldn't think of using the same tool holding for both of those stages of production. They are different, and the tool holding behind them has to be considered differently whenever you're working on a very large part or even a small part in some cases. So considering those as different strategies has to be kind of a baseline for any type of operation.
Awesome. Well, thank you very much, John. And we will stay with you for this next one. So how has the growth of aggressive machining strategies like high feed milling, increasing the use of 5-axis machining and harder materials affected how tool holding and work holding is being used and also how it's being developed?
So like I mentioned kind of at the very beginning, when you're doing high efficiency milling, you are generating a lot of axial pullout force because you're using more, if not all, of the flute length of a cutting tool. You're not trying to gain a huge amount of radial engagement, but you're trying to use the length of the tool to be more efficient, because now you are dealing with a different ratio of material removal rate, rather than using just the end of the cutting tool to try and take a smaller amount of material. So that higher retention, axial pullout force has to be worked against with a higher clamping force tool holder. And so we've developed a newer type of milling chuck for particularly the smaller end of the diameter ranges, so 12 millimeters and below, half inch and below milling cutters, because you're going to be generally using these smaller cutting tools to generate those final finishes, like I mentioned earlier, or for doing heavier stock removal on a smaller workpiece or a smaller cutting tool. Those cutting loads can't be resisted by a very large diameter tool holder. You need something that's geared more towards that. And so our newer Mega 12 DS program and the HMC 12 program are all geared towards that by having a higher clamping force on the tool holder. You're able to resist those retention forces trying to pull the cutting tool out of the tool holder.
Awesome. Thank you, John. So Larry, we'll ask you the same question when it does come to the growth of aggressive machining like high feed milling, also the increased use of 5-axis machining and harder materials. How has that affected work holding and how it's being developed and used?
It's creating the need to evaluate rigidity. It's creating it's creating the ability to look at a part and see what the most realistic and commonsensical application or solution you can give a customer. In our stationary work holding, we offer something called Sinter Grip, which actually offers a self-dimpling feature for a roughing feature and sometimes semi-finishing feature, where it literally holds the part on a 3 millimeter ledge and allows you to clamp a part and mill way high, very tall, very high up on the part without having any loss of grip force or any movement of the part. We do the same thing with chucking, keep it as close to the face of the chuck as you can while gripping the part in the correct method without creating secondary work to have to be done to hide the marks that you provided or hide the clamping marks that you leave with work holding. When it comes to tool holding, again, shorter, more robust tool holding coupled with very rigid short work holding and giving flexibility is the main feature or the main end result of anything that you look at.
Awesome. Thank you, Larry. So we will stay with you for this next one. Now, this is something that you guys have both already touched on, it seems like, but when it comes time to have tool holding and work holding technology, how is automation or robotics kind of being worked into that?
It's actually creating a whole new market. Automation has made it necessary for us to look at things in a different light. We have to have the ability now to have part presence sensing. We developed a feature because generally in Op 10 or your first operations, because you're on a as cast or as cut surface, you generally lose the ability to do that because air sensing needs a flat surface. We've developed an electronic sensing unit that doesn't care what the surface condition is. I can adjust the tolerance of the band to accommodate the out of flatness position, but still give a nice rigid Op 10 machining process. So when I flip it over and go to my second or third operation, I've qualified my part and everything from there becomes simpler and less struggle for work holding. But again, rigidity is what it's all about. And flexibility again, I know I'm beating that word to death, but the more flexible you allow your work holding to be and the more rigid you can be with that flexibility, you really have a winning combination.
Thank you very much, Larry. So John, same question to you at Big Daishawa. How are you seeing automation and robotics affect tool holding and work holding?
So when it comes to tool holding, there's really no huge way to automate assembly or taking a tool from the assembly station to a machine. That's still a person generally loading a tool in that manner. However, what we have found is that eliminating the error that is occurring from a person trying to measure a tool, that is where you can automate the tool measuring process by using a tool presetting machine. By doing an automatic measurement of that tool, you can then eliminate a person trying to guess at what information is important. You can pre-program tool measurements and then take that data and then automatically over a network or via other methods, move that data from the machining, from the tool presetter over to the machining center. So it's a data transfer process, which kind of, you can kind of think of it in a way as a automation, but the physical assembly of the tool is still a manual process. When it comes to work holding, I think the biggest kind of automation that we've seen is more palletized systems being loaded and unloaded versus just parts being placed from bins onto work holding. That has been around for ages and ages, but more and more companies are finding the benefit of a palletized automation system as a benefit, because now they are pre-loading the pallets with blanks and picking up those pallets. So that's where I've seen on the work holding side, although we don't offer it, there have been a lot of new companies that have offered palletization and robotic systems to load those in and out of the machine.
Thank you very much, John. So at Big Daishawa, how are you also then seeing the industrial Internet of Things or Industry 4.0 being used when it does come to tool holding and work holding?
So keeping in mind the tool presetting options that are available, that is all capable, if need be, to be networked. CAD data for tool holders generally is something that if you needed to, you can include that into your tool management system. But one of the things that we're looking at when it comes to Industry 4.0 and making things more available online, that's easy enough. We put, a lot of companies like us have put models available on websites. But when it comes to using the internet as a tool or other forms of electronics as tools, our new EWA auto boring head that we're looking to release this year uses a very simple application that you can use on your phone just to monitor it. So in that application, even if you're not using the EWA head and you're using one of our digital boring heads, all the information that you need to be able to connect to that boring head, even our standard heads, all the application data, manuals, it's all available to you online or via the app. So when it comes to interconnecting things, you can start very simply by making data available, or you can go all the way up to fully controlled, maybe not so much over the internet, but as a closed loop on the machine. There are ways to include technology in pretty much anything that you need.
Awesome. Thank you, John. So Larry, I'll ask you the same question at SMW Auto Block. How is the industrial Internet of Things and Industry 4.0 being used with work holding?
It's actually a big part of our new development and presentation of new product. From about a year and a half to 2 years ago forward, everything we designed is in mind of Industry 4.0 or Internet of Things. From our non-contact transfer of power and data, to our linear positioning systems, to our grip force meters, all the way down to our service and product manuals. Everything is available now over the internet and can be transmitted digitally. The biggest feature of Industry 4.0, or one of the biggest things you should consider when implementing Industry 4.0 is security, internal and external. What kind of data you expect to get out of this? Is the system you're using capable of producing that data? And if not, is the company willing to do the research and development it's going to take to provide that data? It's very important to have a partner that has flexibility and at the same time has the ability to react quickly and with an economic way of implementing Industry 4.0, because it generally starts small. People generally still think of Industry 4.0 as, oh, I can look at it on my cell phone. That's a very small part of the Internet of Things. The Internet of Things is actually interconnecting components from your system to the outside world. And everything we design now has that in mind with our new designs, whether it be electronic, binary, digital, through a bus interface, through an Ethernet interface, whatever the case may be. In fact, we've gone to the next step now, where we've actually developed a whole division called SMW Electronics that has its own separate facility in Europe now to do nothing but development of new products that are interconnected, whether it be hybrid versions, which are digital or electric with mechanical capabilities still built in, all the way up to a fully electric, no hydraulic oil, totally sealed, totally closed unit. But it has the ability to adapt to their existing situation or be built into a machine tool. And there's some special features we offer and some special things we do that make it successful from the beginning.
Thank you, Larry. So another industry that seems to just be increasing and kind of spilling into all of the other industries. We have additive manufacturing or 3D printing. So how are you seeing those industries work into tool holding and work holding?
From a work holding standpoint, 3D printing has become probably one of the biggest advantages and advantages that we have. Because now, instead of putting it on a piece of paper, doing an FEA analysis and guessing that, okay, this all looks in a perfect world, this is going to work. Now we can print a set of jaws, a locator base, throw them on a chuck in the shop, put it on a machine and go, oh, this was a bad idea. Or, wow, that's a great idea. And here's where we can make improvements. From a hybrid manufacturing or an additive manufacturing standpoint, the biggest effect it has on work holding is the ability to present the part without putting it in a position where it's going to get damaged during that additive manufacturing. We are in the process now of implementing both in our own facility. We have budgeted this year quite a bit of money to implement 3D printing and additive manufacturing in our own facility to put unlike materials into a fixture component that gives it better durability, longer life, and again, as much flexibility to put into the part.
Awesome. Thank you, Larry. So we go to John with the same question. At Big Dai Shawa, how are you seeing additive manufacturing or 3D printing being used when it does come to tool holding and work holding?
So one of the things that I've found a lot of customers have been taking advantage of 3D printing is the ability to include into that 3D print features that are going to be used for their work holding going forward. So if a part has a shoulder that it needs for a locating feature or a pilot, you can include that into the 3D print, and then if you need to subsequently remove it later on, rather than having a giant billet of material that you have to cut away entirely to get a part out of it. If you know it's going to end up in a certain type of work holding, a chuck or a special type of fixture, you can build that feature into the workpiece part itself. And then that way you don't have to have all this extra material that goes to waste.
Awesome. Thank you very much, John. So we are just about wrapped up, but I do have one last question for both of you. So let's say we do this same conversation in, let's say 5 to 10 years. John, we'll start with you. What are the biggest changes that you see coming to the industry as far as tool holding and work holding? Like I said, in the next, we'll say 5 to 10 years.
So from our standpoint, obviously interconnectivity of different types of tool holders. I could certainly see a situation where, because we also sell angle heads or aggregate heads, as other people know them, taking an angle head and being able to monitor it in terms of its temperature, sound, not necessarily so much about being able to control it, but just being able to get information off of it. I could see a situation where that could be something that we could look at implementing in the future. One of the products that we recently released and are hoping to add more onto are hydraulic tool holders for Swiss style lathes. For a long time, that market had been dominated by small collet chucks, which are a pain to deal with. So by looking at a different type of clamping technology, a hydraulic holder, we were able to meet the needs of a specific customer, and so we developed a program around it, and now we're adding more to it. So expanding that is going to be something that I think a lot of customers in that market, which traditionally for us have never been a very big part of our business. The Swiss market is something that we're targeting, and by offering different types of tool holders for those interfaces is going to be a key thing for us going forward.
Awesome. Thank you very much, John. So Larry, we will wrap up with you. 5 to 10 years, if we have this conversation, what are the things that SMW Auto Block will be working on?
Well, in 10 years, I won't be here, so I hope they're still working and moving ahead. But no, I believe that you'll see that the integration of Industry 4.0, the ability to incorporate electronics into different components or electrical connectivity between multiple components, I think is going to have to come into every part of our industry. You know, if you realize, if you look back where it really started, you know, machines had the ability to detect location. So if you moved a machine, it wasn't able to run until you had that machine reset. I think you're going to see that not only with machining, but you're going to have work holding, you're going to have tooling. Everything is going to work in sync. I'm afraid when the power goes out, but kidding. But reality is, you know, and that's the other thing, safety features that are built into electrical interfaces. You know, that's something that we've been very aware of and very cognizant of in the design of our product, is if the power goes out and all of a sudden you lose the ability to clamp and unclamp that part, our part will never unclamp because there's a mechanical interlock that won't allow that to happen. Machines have implements for the same thing. I'm sure tooling has the same thing. But I think you're going to see interconnectivity in the future is going to be mandatory. And I think if you don't have it, you're going to be out of business, or you're going to be selling manual chucks, basically. So
awesome. Now, once again, I would like to thank John Zaya and also Larry Robbins joining us today from Big Daishawa and SMW Auto Block, respectively. So, gentlemen, thank you so much for your time. We hope everyone out there has a very great rest of your day.
Jake, thank you very much. And to the audience, thank you for giving us your time and your focus.
Thank you as well. Have a good day.
You can find more Manufacturing Matters plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcast, or on our websites at todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, and evdesignandmanufacturing.com.